Trent, if you could do me a favor and just pick up your mic real quick, do a mic check for me. Hello, hello, hello.
Looks like Ryan's back.
Yeah.
Hi, Ryan. It's okay, Trent. Just help us out by chatting and using that chat box.
It looks like everybody all just was like, hey, let's all come in at the same time. But we did mic checks quick, so that was awesome. That worked perfect. Sorry, Ryan.
Well, I'm glad you're back, though. Yeah. So as we go through and we get started today, since it is just 2 o'clock, what is everybody's favorite game show? What do you like? What is your favorite game show, Miss Bianca?
Favorite game show would be probably a tie between Family Feud and Minute to Win It. Family Feud, because it's flipping hysterical, especially those ridiculous answers that you sometimes hear. And then the faces of Steve Harvey is priceless. And Minute to Win It, because that's just a blast. I want to do that. I'm always telling people in my family, I'm like, we're Minute to Win It. Let's do it. How about you guys?
Yeah, how about you guys? Jeopardy.
Nice. Smart cookie over there. I would definitely not win Jeopardy. Unless you put math questions up there, then that's my jam.
Family Feud. You don't watch game shows? Okay. What about I say game shows sometimes come down to reality shows too, because it's still a game, right? The big game show that ends tonight. I mean, I'm not a big fan, but I know it ends tonight. It's that Big Brother. That's a game show.
I've never really watched that. But if game show was an option, football. There you go. It's a game. That's for sure.
That's true.
Awesome. Yeah.
Hey,
but Fear Factor. Yeah, I forgot about that one. That's so funny.
Oldie but a good one. Goodie, that's for sure.
Yeah.
I think it came back.
Did it?
And then it went away again. I think somebody else hosted. I think it was one of those no, that was the Minute to Win It. I was gonna say the skating person, but that's Minute to Win It.
Yeah.
Deal or No Deal.
Gotcha. Yeah, that's a fun one too. The pressure's on there, because you're like, okay, do I take this $64,000 that's offered to me that I'll probably never see it again in my life, or go for the big win? Survivor, definitely. That's another fun one too.
Well, let's get started, because I don't obviously want to make sure that your time is very valuable to us. So I wanted to, Titan Games. Yeah, it's a new one. That's a good one too. Ellen. Okay. Well, we're glad for you guys to be here. So here's what this is going to be like. If you've been to a live lesson before, it's not going to be anything like that. Okay. Our job today is to help you. That's why it's a Module 3 review. And our questions and our path is going to be chosen by you. All right. And we're going to get more of that in just a second. But before we do, who is ready for a challenge? I guess no one, because it won't let me do anything. There it goes. Ready.
The technology gremlins are not in our favor today.
Is it working? You hear it?
No, we can't hear it. They can still see it, but they can't hear it.
Knock them down and off.
There we go. Awesome.
The game is rapid fire. Michelle Squared, you have a minute to win it. Every second counts.
The game begins in 3, 2, 1.
Keep firing, ladies. Come on. There we go. Nice. Very nice. Almost there. They'll both need one more. 35 seconds, ladies. Come on. You got one.
You got this, Shell. You got this. Lean forward all your might. I'm proud of
Last
you.
one, 25
I have full
seconds.
faith in you. Down a little lower. Focus on the prize. You got this. Come on.
So
Hold on.
close.
You got 15 seconds.
Boom! Locking it in for 10,000 guaranteed dollars. That's what
Just
I'm
crazy.
talking about. One
$10,000 for knocking those things down.
I'll take it.
So what we're going to do today is we are going to have a challenge board, okay? And what that's going to look like is this, all right? Where we're going to ask you to ask us some questions. But before we get into the challenge board, we want to know more about you, okay? So I'm going to share a poll, right? And I want you to answer these 3 questions. Now, the 3 answers that you can give me is number 1, you can say, I've got this, okay? That just means that you understand it, you could teach it, you're feeling comfortable with it. Answer number 2 is, I've been acting okay, but I'm not. You feel okay about it, but you need a little bit more help. And then, of course, answer number 3 is from Mulan, which just came out, obviously. I don't think I can do this. All right, so those are the 3 answers. I want you to be as honest as you can because it's going to help us gear your lesson to what is the most important thing for this class. So I'm going to launch this poll. If you could, 3 questions. Again, 3 answers. You choose one of them. I'm going to give you a couple seconds to do so.
Wow, Nino. We don't have to try to be cool. We are cool. Mr. Hicks and I are the coolest geometry teachers that ever have existed. You just get to be lucky enough to be in here with us.
That's right. Okay, 3. So we have 3.
We're still waiting on a couple more students. If you guys could get those responses in, please. This helps us kind of gauge where we need to go a little bit better.
I'm going to give you about 30 more seconds to get those answers in.
So waiting on one more.
Okay, get your answer in. I'm about to end the poll. In 3, 2, 1. Okay. So I'm going to share with you what I can see and what Mrs. Cavibianco can see. All right. So in our first question, how do you feel about using a scale factor to find the missing side? It was kind of mixed, but for the most part, we see that most of us is you feel okay, but you might need some help. Okay. Number 2, all right. We see that everyone feels a lot more comfortable with this. Okay.
That's okay, Trent.
That's fine, Trent. Not a big deal. And then finally, the last one. All right, our last one was predominantly this one right here. Oop, I'm using the wrong sheet. 1 second, guys. For the most part, it was, again, we're feeling okay. We might need some help. There was some people in number 3, which was not happen in 1 or 2, that said, I don't understand it at all. So I would say that that is probably our biggest one, which is finding the error in the proof. And then from there is probably the scale factor. And then I feel like proving two triangles are similar and doing that is probably a lot easier. A lot of what people are thinking they feel much better about. All right, but we want your help. So we want you to help us with this lesson. So Ms. Capiello, can you take that first question?
All right, awesome. So, and also I want to point out to you guys that on the proof related questions, that's actually one of the things that we found was one of the most common misconceptions or misunderstandings when it came to the segment exams as well. So you guys will have even an added benefit. Not only are you going to get some help for your 308 quiz or Module 3 in general, but you'll also have kind of a heads up going into the segment exam, how to be better prepared for some of those proof related questions. So as you can see on these little buttons here on our little challenge board, there's some different topics. If somebody could please pick up the mic real quick and tell me what topic you would like us to start with.
Correct the info. The
Correct
proof.
the info. All right. Got it. Correct the proof. The green button. Sounds good. So Mr. Hicks, if you want us to bring us to that correct the proof challenge question, and I am confident that you guys are going to be able to help us get through this. Okay, so on this question, this I'm sure you guys have seen even in other modules where it's like, okay, so who is correct or where is the mistake or that kind of thing. So as you can see here, where's my little annotate? Hang on, let me get my little annotate button. Okay. So as you can see here, we can either say they are both correct, or just Jack is correct, or just Stacy is correct, or neither of them are correct. Okay. So what we want to do is we want to compare this picture that we're given here along with the given information, and then try to see what we can figure out with the proof. What was stated differently? Nino, please stop writing on the board for me. All right, so thank you, I appreciate it. I love that you're getting involved, but we just want to make sure that it stays math related to make the best out of everybody's time. All right, so now my personal approach to questions like this and how I typically teach students to do it is to use visual aids, because visual aids really help us to make some connections that sometimes we don't see when we just like read words, okay? So I would look at things like midpoint and I would say, okay, so what does that mean for me? Well, I know that if I is a midpoint, that means that I'm cutting, it is being cut into two equal parts. So if I is the midpoint of XM, then I can say that this piece is equal to this piece, okay? Is there somebody that can tell me that something else I might be able to mark on here as congruent based on the given information? Is there something else based on the given?
Transverse.
Okay, so somebody said O and A, and then what was the other thing?
Transversal.
Okay, yeah, so this, the like AO could be, it's called a transversal, just as XM could be called a transversal. Awesome, great vocabulary words, I love that. And Nino, great job. So we know that these, where the little red arrows are, we can say that those are equal. Anybody know what justification we can use on how do we know that this angle and this angle are equal? What type of angles are those?
Alternate exterior.
Okay, so oh, go ahead. Did you have something else to say on that?
Oh, is it?
It is not alternate exterior. Very good job, Nino. So those are what we call vertical angles. When we have two lines that intersect, then the lines, or the angles rather, that are opposite each other, they're kind of like backwards V's, or we can say they share a vertex but don't share any sides. Those are what we call vertical angles, and vertical angles are always equal. With the alternate angles, if you had alternate interior, we could say that this angle and this angle are equal by alternate interior angles. That might have been more of what you were thinking. All right, awesome. So let me just check the chat real quick here. Obtuse is bigger than right angles. That's absolutely true. But when we're dealing with geometry or math in general, but it's really specifically to geometry, we don't ever want to go with what we think is true or it looks like it's true. We don't want to say, oh, they are obtuse or they are acute or they are right. We don't want to make an assumption based on what we think it looks like. We want to only make statements that are absolutely concrete fact. We know that it's true because of such and such theorem or because of a postulate, okay? Because of a definition, that type of thing. All right, so the other thing that I was looking for here, which we had some excellent answers, I love it, loving the involvement, was that these two segments are also congruent because they said I is also the midpoint of AO. Okay. All right. So now, if I come back over to the proof, hang on, let me get this chat over here. All right. So I'm going to come over here and now I'm going to evaluate what was said and compare it to what I already know based on what I've marked here on the triangle. So we want to look at with Stacy. She says I is the midpoint of XM is given. Okay. So guys, if you guys could limit your chat, please, to only stuff relating to what we're doing here. I love that you guys are laughing. I love that you guys are getting involved and communicating. That's awesome. We definitely like to see involvement between students, but we also don't want anybody to get distracted. Okay, so we definitely want to make sure to make the most out of this time. You don't have to be sorry. Don't worry. Just want to make sure that we're keeping focused is all. Okay. All right. So Stacy says I is the midpoint of XM, which is absolutely true. That was given to me. So I know that I'm happy with that statement. So I'm going to give that a check mark. Okay. And this person said the same thing. So we're good there. They also both said that XI equals IM definition of midpoint, which we've already said that that is also true. And they also restated this given I is the midpoint of AO. So far, they're both on the same track, right? We haven't found any errors. And we said over here, AI equals IO. That was the definition of midpoint. So we're still definitely in agreement. But if you notice here on statement 5 and here on statement 5, here's where we have a difference. So it could be that one of them is right, or it could be that neither of them are right. We got to kind of look into that. So looking at Stacy, she says angle AIX and OIM are vertical angles. Therefore, they are congruent. Did we say that that is true? Very good. People are putting some check marks up there. I love it. Loving to see that people are even using the technology here. So I'm still in agreement with her. Okay. Now, then when I look at these triangles, do I see, and hang on, I'm going to, I don't know how to remove just one thing. I don't think I can because I'm not the presenter. So I'm going to mark with a black marker that they never said this was true in the proof, and they never said this was true in the proof. Therefore, I can't use it right now. So just based on what is marked in red, do we have ASA for triangle congruence? So just based on the fact that this and this and this are true, is that ASA? I am actually not in agreement with the ASA part. So yes, exactly. Great job, Emma. So that is SAS. We have a side and then an angle and then a side. So that is SAS. Okay. We have a side and then an angle and then a side. Okay. So that is SAS. All right, Nino, don't worry. I will definitely get you unconfused. I promise. Okay. So what we have here, and I'm going to go ahead and clear everything just to make it a little bit easier for us to see. If I
You sure?
tell you that
You don't want-
this angle and this angle are congruent.
You don't like it? Do you like the other one more than this one?
Hang on. Somebody's on off mute.
You both did.
Mr. Hicks, are you
Thank you,
able
Leslie. Thank
to
you.
unmute and mute them?
I can't
Oh,
right
I
now.
can,
Sorry.
I can do it. I can do it. It's okay. I got it.
Apologize.
Nope, don't worry about it. I know your screen went down, so I got it figured out. Don't worry. All right. So now on the side, we said that this side was this side and this side was congruent to this side. So that's why we had the SAS. If we wanted the ASA, what we would have to have is that the A and the A, that means we have two sets of congruent angles. And since the S is between the A's, then we have to have the congruent side between the congruent angles. Okay, so that would be something like A, S, A. That would be ASA. Okay. All right. So I am not sure how to pronounce your name, whether it's Nino or Nino. I apologize if I'm mispronouncing it, but unfortunately, I'm going to ask you one more time to please not add disruptions to the lesson. I don't want to have to remove you from the class. I've never had to remove anybody from a lesson before, but I really need you to not have distractions, please. Okay. Thank you. All right, and I apologize, guys, for the disruptions. That's not normal. We have not really had issues with that before, so I do apologize for that. All right, so do we understand the visual, though, now between ASA versus SAS? Is there anybody that feels like they don't quite get that? Okay, I'm going to go with no. I don't hear anything on the mics or on the chat. Okay, so now getting back to the question then, hang on, there we go. So we said that this is not going to work. So therefore, we now know that Stacy is wrong. Now, had she said SAS, then yes, she would have been correct. We would have said that she was correct because this got to check, 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 but this did not match. Okay, all right, awesome. Okay, so now on Jack, we already said that these are all true. Now, are AIX and OIM supplementary angles? Well, that's going to be another microphone question. Can somebody please, on the microphone, just tell me real quick, what does supplementary angles mean?
It means that they would, one added together equal 180.
Perfect, Gage. Thank you. I love it. So, do we have enough information to say that these are going to be supplementary angles? Anybody on the mic or chat? Do we have enough information to determine that those two angles are supplementary angles? No. Very good. They could be. In the case that they were both right angles, they could have been, but they don't have to be. So we cannot say this. Therefore, we can automatically stop and say Jack is not right either. So the correct answer here is neither. Neither one of them are correct. Okay. Any questions on this one?
And just to answer Nolan's question about I'm not sure. A big thing about supplementary angles is that they need to add to 180, as we talked about. And so these are showing that they're equal to each other. So that would never be able to be possible. So that's why another reason why they're not equal. That they're not equal. That wouldn't be correct for Jack, being supplementary.
Yeah, and also another way to think of like supplementary, like if I showed you these two angles, these we could absolutely guarantee conclude 100% of the time they're going to add to 180 because they form this straight line here at the bottom. Any two angles that form a straight line are always supplementary. So that's why I was saying like on here, they could have been In the case that they happen to be both right angles, then yeah, okay, those would technically be supplementary, but it's not a rule. There's no rule that says vertical angles are supplementary. Does that make more sense?
Does anybody else have any questions on this? Because we don't want to move forward before we feel comfortable.
Awesome. Good stuff. All right, so let's go back to that home board, and we want you guys to give us another topic, okay? And I want to encourage you to step out of the comfort zone. Make sure that you don't pick a question if you're like, oh, I know I've got this one. Try not to pick that one. Try to pick the one that maybe makes you a little bit more uncomfortable. Triangle properties?
Proportionality.
Oh,
Yep.
proportionalities. Gotcha. Okay, yeah.
Gotcha.
Awesome.
Okay, so triangle proportionality. We have a triangle here. I'm gonna get my fun little spotlight. Okay, we have our triangle here of EDF. Okay, we have a line VU in the middle of our section. All right, and we are trying to find the measurement of DF. Okay, awesome, Nolan. Can you pick up the microphone? What would we do? What would we do, Nolan? Sorry. Uh-oh. Maybe his microphone's not working. Anybody else has a microphone that wants to be a helper today?
Can you hear me? I'm sorry.
I can. Oh, I can hear you.
Okay. Okay. So if we're asking how do we solve this?
Correct. Well, like we're going to use the triangle proportionality theorem. How would we find the measurement of DF? Yes, no.
DF. So I think. I know that the two triangles are congruent because EUV fits inside D FE. EDF. So I know that they're congruent.
Similar.
Similar, right? Not
Yeah. I know what you
let me
meant,
think.
though.
Mm-hmm. So I'm not necessarily sure. All I know is that the angles are equal to each other.
Gotcha. Okay, so you could be able to use triangle proportionality here to prove that they're equal to each other, right? Or similar in this fact. So we would have two sides that are similar, right? And these two, that's what we're showing. We know that they all both share angle E, right? Because one's EVU, one's EDF. They both have angle E. And we could also prove by corresponding angles. EVU is equal to EDF because they're corresponding. So there's a lot of ways that we can prove similarity. All right. But here is a portion of that triangle proportionality theorem that we need to make sure that we know. Okay. So first, it is a line that is parallel to one side of the triangle. So it intersects the other two sides, which that is VU. Okay. Again, VU is a line that is parallel to DF, and it intersects the other two sides and it splits them proportionally or similar, makes the sides similar to each other. It also states that the sides are divided proportionally and the inside side is 1/2 of the length of DF. So if VU is 9, then what would be DF? What would be DF?
4.518.
Well, you went the opposite way. VU should be smaller than DF.
Yeah.
So Gage said 18, and Gage, you would be correct. Yes. Okay. So we have to multiply it by 2, and 9 times 2 is 18. Okay. So again, when it comes to this problem, first we need to know the actual theorem. And that's something that's going to be in your notes. Okay. You need to make sure that you have that second part, which states that the side in the middle is 1/2 the length of the outside side or its base. Okay. Any questions on that, guys and girls and everybody? Okay. Give me a second. Yeah, no problem, Nolan. Take your time. Well, that one was one of those that if you know the theorem, right, you can easily solve the problem, right? Just make sure that if you had DF, you would have to half it to get to VU. And as we did here, we multiplied it by 2 or did the opposite to find DF. You good now, Nolan? Okay, let's go back.
All right, leaders, where are we going next? You guys are doing awesome. I'm so happy to see a couple of my guys, by the way, in here today. Go ahead.
Triangle side length.
I think somebody else was saying something too. What
Oh,
was
go
the other
ahead.
one? So we can do both of those. We'll do those next.
Compare terminology.
Okay. All right. So we'll do both of those. Compare terminology and we'll do finding a side length.
You got it. All right. You want to go? Which one do you want to do first, Ms. Caviaco?
Oh, it doesn't matter. We can jump on this one.
Okay.
So this one's a pretty quick one. So basically for comparing terminology, if you notice like from module 2 and module 3, they really tie in a lot together. Both of them are dealing with transformations. Module 2, of course, was the rigid transformations, translation, rotation, reflection. And then module 3 came along and said, hey, now we're going to dilate. But we still have some of the similar postulates. So we had side angle side for triangle congruence. And then module 3 came in and said, okay, now we have side angle side similarity. So we want to be able to compare the two. We want to be able to understand like, how are they similar or how do I know which one I'm dealing with? So the first question would be, when you guys are looking at these pictures, which one would you say would be triangle side angle side congruence, or which one do you think would be side angle side for similarity?
The one on the left would be congruence and the one on the right would be similarity.
Very good. Okay. Now, what makes you say that though?
Well, just by looking at it, you can kind of tell that the one on the left, they look like equal in all measurements, but then the one on the right, the triangle on the top looks a bit bigger. Okay,
I love what you're saying, but we do want to also be able to expand on that a little bit, because if you remember what I had said in one of the earlier questions, in geometry, we really don't want to rely on it looks like, or I think, or it appears to be. We want to just go with absolute true statements of fact. Okay, so we can say that like this right here with the 2 tick marks and this right here with the 2 tick marks, that absolutely means congruence. So we absolutely know that RS is congruent to S. I don't see what the other letter is that got covered up. Oh, B. So that would be, that would definitely be the side angle side for congruence. And then as you can see on the figure on the right, we're given all sorts of different numbers and even variables. So this one would be that side angle side similarity, where we would say, okay, so 75 over 30 equals 45 over 3x minus 21. And then we would actually be able to solve for one of the missing side lengths if that was what we wanted to do. So both side angle side similarity and congruence are both going to follow the same order of information, as far as, you know, like what I was saying with, whoa, where's my drawing? There it is. So if I have a triangle for side angle side, remember it's going to deal with any 2 sides, but the angle then has to be specific. It has to be the angle between the 2 sides. It cannot be. In fact, the vocabulary term for that is the included angle. It couldn't have been one of these angles over here, because those would not be side angle side. That could have been like an angle side angle or an angle side or something like that, but it could not have been side angle side. Does that make sense? Anybody having any questions?
Doing good over here.
right. So, and that actually leads right into the next question, which Trent had, which was finding a side length. So now Mr. Hicks is going to help with some of you guys participating to talk about how to find this missing side length. Okay.
Okay. So
Was that one?
pretty sure, right? No. I
No,
get there's two of them. That's right. There's two of them. My bad.
Yeah, it's okay.
Awesome.
I think this
Perfect.
one will be easier for
These,
them to
well,
lead
this
into.
one's, yeah, definitely, because it's the same examples. That's going to really help. All right, thank you. So we have our 75. Look at my tools again. All right, we got 75 here. All right, and of course we have 45 in this triangle. So 75 and 45. We got an equation of 3x minus 21, and of course we have 30. So my first question to you is, which side is similar to 75 in the smaller triangle? Which side is similar to 75? Is it 30 or is it 3x minus 21? Which one is? Boom. Yes, 30. That's correct.
30.
Nice, because one, they are on the same line. 75 and 30 are on the same line. Yes, it's being split, but they are on the same line, so they are going to be similar to each other. They both have an alternate interior angle when it comes to it as well. And thank you. Yes, they do have vertical angles. Even better. Nice. All right. So as we go forward, all right, we want to use 70 and 30 to find our scale factor or our dilation. Do you know what our scale factor would be here in this problem? How many times bigger is 75 to 30? $2.5. Yes, that's correct. Okay, so it's 2.5. So we know that I'm sorry, I was reading Trent's question. We know that 2.5 is our scale factor from 75 to 30. All right, and Trent says if the equation to solve 3x minus 21 equals 45. No, that is a good thought though, Trent. No, it is not in this equation, because we're going to show you why in a second. Ms. Capabianco just did. It's proportional. That is correct. So
Sorry.
45. No, you're good. You're good. I'm sorry. I'm just behind the chat. So we can do it two ways. First way that we can do this, all right, is we can use the scale factor of 75 and 30 and use that to solve for 45 and 2.5. Or we can set it up as a proportion. Okay, do you see the proportion here? All right, we have a proportion where we do 75 over 30, 45 over 3x minus 21. All right, who feels more comfortable? How big this is? We have a raise your hand tool, right? Let's do the green check mark. Who feels more comfortable, green check or yes, if you feel like you would like to do the proportion, or red X or no if you feel like you'd rather use the scale factor? Which way? Just go to your participants, your list, and hit the button. There we go. There's one green, 3. Ms. Capabianco says green too. That's awesome.
Well, especially because we know that they're going to use more of that, typically.
It's true.
I love proportion, the cross multiplication, but to me, I'm like, I don't know.
Well, let's just do it. We're going to do it both ways, but let's just do it first with the proportion, because that was, of course, our main amount of people. So the first thing that we're going to do here is we're going to take 75 and we're going to cross multiply it to our equation 3x minus 21. So we do 75 times 3x and 75 times negative 21, because we have to cross multiply. We need to distribute it to both. We also do the same thing for 30 to 45. We take 30 times 45.
Trent just had a light bulb moment.
So as you see, we've actually evaluated it. Okay, we've made it so it's 225x minus 1,575 equals 30 times 45, which is 1350. Now, what's the next step? What do we do next to solve for x?
Divide.
Divide. Yes, we are going to divide. Before we divide, I want to move
Add.
minus. We're going to add. Perfect. All right, so we're going to add 1575, all right, to both sides. All right, and then as we said, we're going to divide. All right, we're going to divide. So x in this equation equals 18. But that's not what the side length equals, right? To find the side length, we'd have to put it back into our equation of 3x minus 21. Can anybody tell me what's 3 times 18 or 3 times x? $54, that's correct. Okay, perfect. All right. And we're going to subtract that by 21. What's 54 minus 21? $33. So what you guys have done for us, okay, has you really helped us out because we see a mistake on this slide. So thank you so much. Okay, so 54 minus 21 is 33. So CM would be 33 as its length. So perfect. Nice job. So that is how you would solve it using proportion. The only difference between solving it with proportion and solving it with that 2.5 is we would take 45 and we would divide it because that triangle's bigger. The other triangle's smaller. We would take 45 and divide it by 2.5. Do you know what 45 divided by 2.5 is? No one's like, no, I don't. I like that. No one's just like, no, I'm good. So 45, good. 45 divided by that is 18. Or am I right here? Somebody got to check my math there. I got a lot of people saying 18, so I'm gonna
tend to. They seem like they agree with you.
Okay,
Got some
great.
cheerleaders over here.
Gotcha. All right, so in that problem, we have, of course, 18. As you see, that would be how we'd find that side would be 18. That would help us solve for our answer in our equation because that's going to be what we're going to use the times and solve. But I would tell you that the best way to do this is to do it from our proportion because the proportion is going to really help you solve this equation quickly and not make any simple mistakes. Any questions on that, guys?
Awesome.
Okay.
When Nolan said no, when you asked him if he could do the calculation, it reminded me of a DBA I did the other day with tutoring. And I was asking with the proof, I said, what's the one thing, what statement are we not allowed to use to justify proving vertical angles are congruent? The student said, because I said so. I said, well, I guess technically you're right. So Nolan, you gave me a good laugh there, my dear. All right, so we go back to that main slide. I think we got time for one more question.
Yes, we do. But
that would be me, Nolan says.
I don't know what just happened.
Technically you're right, but
my screen just
froze.
All
right.
Of course it did.
as Mr. Hicks is getting his computer unfroze, what topic do you guys think you want to go over next? We had proving triangles are similar. We had determining scale factor. We had finding out which triangles are similar. Wink, wink, hint, hint. That is going to be an exam question as well. We had a create your own kind of question. Let's see, what other topics did we have? That one, which one? I just said like 5. Proving which triangles are similar. Okay. So, are you still frozen, Mr. Hicks?
Unfortunately, yes. I think I got the idea, but maybe not. Let's see.
Okay, because I can just do a new share if you want. All right, can you guys see this blank whiteboard now while Mr. Hicks is getting his computer sorted out? All right. Awesome.
Yes.
Okay, so if I tell you that, let's say this line and this line are parallel.
It looks like I'm back, but
Oh,
it's
you
up
are
to
back? Okay,
Yeah.
yep, I'll stop sharing because it's quicker to not create a whole new problem. Just improvising for you guys. Mr. Hicks and I, we just roll with the punches, man. We roll with them as best as we can.
All right, do you see it?
Yep, sure do.
All right, where were we going? Sorry.
Proving similarity.
Proving similarity. You got it.
Awesome. Okay. So on this figure that they give us with the triangle, it's JKL. And then they tell us that JM bisects. And on the microphone, somebody please remind me what that meant, because I just can't remember what bisect means.
Cut it exactly in half.
Very good. I love it. You guys are awesome, man. I love the involvement we're having today. All right, so that tells me I know that this is equal to this because it's cut exactly in half, just as he said. Okay, so, and then they say, okay, so prove then that JMK is congruent to JML. So this is actually confirming module 2, okay, as well as giving us practice with module 3. All right, so they tell us, they state the given, where that's awesome, wonderful, fine and dandy. And what can somebody tell me, what does that little box mean here at angle M? I just don't even know what that means.
It means that it's a right angle.
It does mean that it's a right angle. All 3 of you guys are right in chat and microphone. Awesome job. Thank you so much. Wouldn't have been able to get through that without you. All right, so now I know that these 2 are congruent because they're both right angles. All right, good job. And so then let's see. It says, oh, and then it also says that JM bisects angle J. So that means, let's see if I can get a steady hand enough to do this. So that means this angle is congruent to this angle. That's really hard to do. I could have done it here. I guess this picture is a little bit bigger. All right, awesome. And then we said that this was equal. All right, awesome. Okay, so now what rule, or oh, I'm sorry, then we already said that these angles, we said this one right here, that the angles were equal because they were both right angles. If you want to go ahead and clear that for me, Mr. Hicks. All right, awesome. Okay, and then what rule allows me to say that JM equals JM? What postulate, theorem, definition, what rule allows me to say that JM equals JM? You being a teacher? Well, I don't think that, I mean,
Is it Reflexive.
Yes, I love it. Woohoo! Great job. I love it. Reflexive property. Okay. So, and for those of you that don't know, like on the, oh, great job, Emma. I see that you did it too as well. So for those of you that don't necessarily remember reflexive property, the funniest way that I can think of to explain it is that as much as you might love me and think that I'm awesome, when you look in the mirror, you don't want to see my face, right? You want your reflection to just see you. You might get a little freaked out if you go looking in the mirror and boom, there's Mrs. Capobianco. Okay. Or when I look in the mirror, boom, I don't see Mr. Hicks. Okay. I might jump, get a little scared there. So our reflection is always the equal and exactly thing that was on the other side. Okay. So reflexive property says the same thing. Whatever's over here, JM, needs to be equal to whatever is over here, JM. Okay. Does that help with a little humor to understand that reflexive property? All right. Not seeing any questions. Okay. Good stuff. Thank you, Trent. All right, so now we need to look at this information and we need to see, okay, so what, oh, actually, no, I think we're done. We've, so this was already answered. So it already gave us
Yeah, it
the
was,
box
sorry.
delay. Yeah, that's
It
okay.
wasn't.
So that's all right. So, so we could actually, what's funny about some of these proofs is that I describe it to students as that, you know, proofs are kind of like me asking you, how do I get from your house to your school or to your church or to your grocery store or to your, you know, parents' house or whatever it is. So the route you might go might not be the route that I would go or somebody else. It doesn't make your route wrong. Just like when you go on Google Maps, they'll say, do you want the fastest route or do you want the one with the least amount of tolls or do you want the lowest mileage or, you know, quickest time? So a lot of times with proofs, it's not just one right way. Okay. All right. So any questions on this question?
Hold on a second. For the bisector, if JK is like longer to JM than JL is, even though it's cutting KL in half, wouldn't that mean that it's possible that the ASA would be false because JL would be wider than the opposite side?
So you're saying if JK is longer than which one?
Is longer from the bisector than JL.
It can't be.
No.
Not based on what's given. So because, and that's a great question though. So if I look at, can you give me a blank white screen, Mr. Hicks?
Sure. Let me go to my share. Hold on one second.
Mm-hmm.
You see it now?
No, I'm still, oh, there we go. Yep. Perfect. Okay. So I'm going to just make this a little bit bigger so that it makes it, whoa. I only just see a really thin white line. I don't know what you guys are seeing, but it might take a second to load.
Same.
Okay.
What? Hold on. I'm on mute.
All right, so I'm just going to do a new share for a second because this one is not coming up.
Yeah.
Okay.
Go ahead and do your own.
Yeah. All right.
All right.
So if I have a triangle. All right. And then I have this here. All right. So if I tell you that this is a right angle, then we also know that this has to also be a right angle. Do you guys agree with that?
Yes.
Yes. Okay. And then if I tell you that the angle here is bisected, then that means that these two angles are equal. Do you agree with that? Okay.
Or is it is that the sticking point that you're having? I can't remember who it was.
Yeah, I don't see him jumping in yet. I know he had to.
It was Chris. It was me.
Okay. So, so has everything I said, do you understand what I've said and agree with what
Yes.
I've marked on here? Okay. And do you agree that all of the angles in a triangle add to 180?
Yes.
Yes.
All right, I will throw you an imaginary piece of candy if one of you can tell me what theorem allows me to say that, because you'll definitely want to know that on the 308.
Some
quiz as
theorem?
well. Yay!
Triangle.
All right, what do you want? Snickers, Mr. Goodbar, Twix, M&Ms.
Twix.
All right, I'm throwing it at you. Catch it. You got it?
Woo! Yeah.
Awesome. Okay, it was called the triangle angle sum theorem. Triangle angle sum theorem says that all of the angles in that triangle have to add to 180. So if I know that this angle and this angle are equal, and I know that this angle and this angle are equal, I at least know these two triangles are similar. That was our angle similarity.
Yeah.
And then triangle angle sum theorem even says, oh, wait a second, we know now that this third angle has to also be equal. There is just no way, because if the two angles are the same, then the third angle has to be the same. All right. And then we said this segment here had to be congruent to itself because of the fact that it's a shared side. So that was our reflexive property. And who where's my participants list? Okay, so Chris, it was you that had the question, right?
Yeah.
Okay, awesome. Do you know what an isosceles triangle is?
Not off the top of my head. Sorry.
Anybody else know what an isosceles triangle is? Go ahead, and Trent. What is an isosceles triangle?
Is it like two unequal and one?
All right, so it's actually two equal, not two unequal.
Oh.
So great job, Emma and Trenton and Trent. Yeah, lots of good answers here. So it's two equal sides. So, and then the third side would not be equal. The third side would be something else. So in the isosceles triangle, will also have the base angles will be congruent. And as we can see here of the overall triangle, these two angles are congruent, which means that the legs that form it have to also be congruent. And so we have either angle, side, angle here, angle, side, angle, or we could even use, let's see if I can go to Spotlight, side, angle, side, side, angle, side, or we could have even used hypotenuse leg because it's a right triangle. Shared leg is congruent, hypotenuse is congruent. So as you can see, it's impossible that this length here would be any different than this length here. It wouldn't have been possible just based on what was given. In other triangles, sure, yeah, you could have had a point that was, this was not the same distance as here, but it would not have been an angle bisector and it would not have been perpendicular to the side, because based on that, then these sides would have had to have been equal. Does that make sense?
Yes.
Great question. We really tied in a bunch of concepts on this one. That was great. No worries, Ryan. Sorry you're having trouble getting kicked out. Glad you're back. All right. So any questions on this question? No? All right. So what we're going to do is I'm going to go, Mr. Hicks, do you have your computer back unfrozen?
Yeah, I'm good. Just you let me know when you're good.
I'm going to stop sharing. And we're going to do a couple of things. One is, we are going, sorry, I got distracted by the chat box I was reading there. So we're going to do a couple of things. One is we want to redo that same poll we did at the beginning. And we don't want you fluffing our feathers and just kind of telling us what we want to hear. We want to see honest results here. We want to see, did maybe the I don't think I can do this, did that maybe just come up one step? Or did it come up all the way to the I've got this? We just want to make sure that we have had some improvement. We don't expect that you go from F level understanding to A, but we definitely want to see that we've had growth. So if you guys could answer those questions. And then another thing that we're going to do is we're going to actually Mr. Hicks is fabulous, way better than I am with technology. And he actually created like one of those little scannable things where we're going to be able to get you the whole slideshow. So even the questions we didn't go over today together, you will have access to. You'll be able to see the questions. You'll be able to see the answers. And I would challenge you that as you go through it, don't just look at the answers, look at the questions and see what you can answer on your own. Okay.
And as she's saying, use that QR code. It will have just the questions on there for you to go back and forth, and it should be pretty easy for you to click and move from question to question.
Oh, I didn't even realize. I forgot that we took the answers off.
No. Well, I'm just saying that it's just gonna be it's gonna have the answers on it, but it's gonna have there's not gonna be the video and stuff like that. It's gonna be straight questions and going through it. So. But we do appreciate you guys being here. I'm gonna let you guys finish up the poll before we go back. I want to make sure that you get what you need before you leave today, and that is this. You need to submit this for collaboration credit. If you do not, or you have not attended a 105 or 205, and you want, well, not what you want, you've now attended a collaboration, that's 50 free points. If you haven't done so, please take a picture of this, all right? Answer these questions. And then of course, after you answer the questions, you put it into the collaboration. If you've already done it, then all you're going to do is then put this into your enrichment assignment, the first enrichment assignment. All right, to the very end, you'll get 10 points for doing that as well. So you can either get 50 plus 10, 60 points, or just 10 since you've already attended that. And yes, you would use that. Now you would need a code. Let me get my annotation tool. 1 second. All right, that's the code for this week. Am I right on that?
Mm-hmm.
Okay, just want to make sure I'm not messing up the code. All right. And I'm going to end the polling because everybody's basically voted. And as it looks right now, which was awesome, and we really thank you guys for being here, is that for every single one, the majority was, I got this, which is awesome. Okay. Now we had a couple people that still feeling uncomfortable. We didn't have anyone thinking they were struggling, which is even better. But we ask of you to reach out to either your teacher, myself, or Ms. Cavibianco, if you need any help whatsoever as you get ready for that final exam. Use all of our resources, which are easily clickable on your homepage when you log in. Does anybody have any questions for us before you go today? You submit with both collaboration and enrichment. You can do it for both or just one. Depends on if you've done it or not. All right. Well, you guys have a wonderful day. Thank you so much for being here.
Yes. And Haley engaged. Yay. Thank you so much for coming. I always like seeing my own little kiddos. And thank you to everybody for being so active in your participation. It really helps us so that we make sure that we get through content and do the best job we can for you. It's our pleasure for sure.